Yes, hello everybody. Myself Rajeev, physics faculty. So you all are most welcome in 10 atom physics. Again I'm telling you, I don't want to know you are only my student. If you are not my student, doesn't matter. If you want to share your doubt, your problem, you can share your doubt and problem. If you want to video on any topic, just message me. I will make a video and I will give you that, right? Okay. So 10 atom physics is always stand with you. Whenever you want any kind of help, just post your message or maybe in comment or maybe in my WhatsApp number. Don't worry. Okay. So right now we are going to study gravitational potential. See, we have learned how to find gravitational potential due to ring, due to hollow sphere, due to solid sphere. Now we are going to learn find the gravitational potential due to disk. Right? So see, suppose this is a disk. Okay, this is a disk, and due to this disk at the point P, this distance is x, we have to calculate gravitational potential. It is look like ring, but the thing is that ring has only mass at a periphery, outer surface. Ring has mass only at the periphery, outer surface, right? But disk has mass throughout its surface area. I cannot say throughout the volume because disk has only area, not a volume. Remember, so mass will be throughout its surface area. Okay. Now see how we can calculate. Slice of onion. If we take one slice of onion and just knock at the center, if we knock at the center, then you will find that lot of rings of very small radius start coming out, right? Lot of ring of very small radius start coming out. Just try to understand what I want to say. I want to say and clear you. Disk is basically made up of combination of rings of various radius. I want to say disk is made up of combination of lot of rings of various radius. Like this, take one slice of onion and just know, then you will find that, oh, ring start coming like that. Oh, wow. So we can assume disk has elementary part ring, and we know that ring has what is the gravitational potential. So I will try to take gravitational potential of due to any ring, because your ring has various radius. So gravitational potential due to any ring, and after then we will integrate, because here see, this is a one ring, this is another ring, this is another ring, this is another ring. So we can say that disk is made up of ring of various radius. So we can find gravitational potential due to any ring and add all the rings. So I have already explained, process of addition is called integration. So finally I want to say find the potential due to any ring and integrate them, taking limit what is the minimum radius 0 and what is the maximum radius r. So take the limit from 0 to r, you will get the result. Done, buddy? So just see. So first of all, here distribution of mass is surface distribution. That's called surface mass density. So first of all, find sigma. Sigma is called surface mass density. Surface mass density, and this is basically total mass by area of disk. So area of disk is what? Pi r square. Sigma, first of all you have to learn what is sigma. Sigma is called surface mass density. If it is charged, so we can say surface charge density, but right now mass, so surface mass density, and this is mass by area, because whole mass distributed across the surface. Done, buddy? Okay. This will represent mass per unit area. This will represent mass per unit area. Okay. What is the elementary part of disk? Tell me. Elementary part of disk. I have already explained. Elementary part of disk is what? Radial ring. Because I told you, ring is made up of combination of disk is made up of combination of lot of ring of various radius. So we can say elementary part of disk is ring. Now I move at a distance and select a random radius, or you can say ring of random radius. Suppose that this is a small r of thickness dr. My dear, please look here. I move at a distance random radius and select a ring of random radius having thickness dr. So first of all, I want to calculate gravitational potential due to this ring, and after then integrate, right? Okay. Now see, what is the formula of gravitational potential due to ring? We know that minus gm by under root r square plus x square. We know that this one. Okay. So thing is that first of all they required minus gm. So we need mass of this ring. So how we will calculate mass of this ring? Dm. Because this become a small element for this dx. This ring become a small element for this disk. So I will write here dm, and this becomes sigma into area of this part. So the length is what? 2 pi r. Length become 2 pi r and thickness become dr. So this become mass of a small ring. So due to this small ring, potential becomes minus g dm by under root x square plus r square. Now put the value of dm. Yeah, everybody. Minus g dm become 2 pi sigma r dr divided under root r square plus x square. This is a, my dear, this is a gravitational potential due to this a small ring at point P. But we have right now lot of such rings. So what we can do? We can do integration. So first of all, my one question to all of you. Here which is variable? X variable or a small r variable? So simply you can say as x is always constant because it is not going to change. It is from center. See, x is constant. It is not going to change. Why? Because it is center, and center of all ring is same. So what is going to change? Radius of all ring is going to change. Suppose I select this ring. Someone selecting this ring. Someone selecting this ring. Someone selecting this ring. It means this small r will be here variable. So now integrate this. So see, v is equal to integration of dv, and I told you here lot of ring. Minimum radius of ring will be 0 and maximum radius of ring will be capital R. Here which is variable? Small r is variable, x is constant. This all are constant, take outside. Now the thing is that how we can integrate to this one? How we can integrate to this one? So I have already explained you. This is not a normal case, this is an abnormal case. So we can do this integration by substitution method. Here is a lot of substitution method. Either you can put r is equal to x tan theta, right? Or simply just see, this is the equation first. This is the inside the root. So I have already told whenever something inside root, to take t square. So I am going to assume this is the x square plus r square is equal to t square. Okay, my dear, this function become, if you put this one t square, so this is become function of t. So at the function of t you need dt. So just find from here. X square is what? Constant. If you differentiate this one, so I told you x is what? Constant. This becomes 0. This is variable. So what is the differentiation of x square? 2x. So differentiation of r square become 2r. And this is a function of r. So dr. Similarly, differentiation of t square become 2t. And function of t, so dt. 2 get cancelled. So r dr is equal to becomes t dt. Now my dear, from equation first, at this place, what can I can put? T dt. Getting my points? Okay. So just see, here I am going to put t dt because at this place t dt. Okay, what I can put here? So at the place of x square r square, I can put t square. So this will come outside. See, at this place I put here t square. So this will what happen? Come outside the root. It will come outside the root. This become t. But limit will be changed. Why? Because this limit taken 0 to r when radius is variable. But right now what is variable? Right now t is variable. So take the limit of t. See, when radius will be 0, what will be limit of t? X. So when radius is when radius is 0, limit of or value of t will be x. Okay. When radius is capital R, so value of t will be under root x square plus capital R square. So this limit become x square plus capital R square. Done, buddy? Now solve fast. T get cancelled. So V is equal to coming minus 2 pi z into sigma. This is not a sigma. T get cancelled. So integration of dt become t. Integration of dt becomes t, and this is the lower limit x. This is the upper limit r square plus x square. So this becomes minus 2 pi z sigma. And we know that how to put the limit. First of all, put upper limit. So upper limit become r square plus x square minus lower limit. So this is the value of gravitational potential due to this. This is the value of gravitational potential due to this. You can find the value at the center. Just see. So see, at center x is equal to 0. So VC becomes minus 2 pi z into sigma. Here this becomes 0. This is also 0. So this becomes r. So potential becomes here, sir, minus 2 pi r into z into sigma. And I have already told you, sigma is what? Mass density. So mass by area pi r square. This is the mass density. If you want to find result in the terms of mass, so replace sigma by gm by pi r square. So this all get cancelled. So you will find the result in the terms of mass. So this is a gravitational potential due to disk. Again, it's my humble request, if you are stuck in anywhere in any topic of physics, you are most welcome. You plot your doubt, you post your comment. I will make a video and definitely I will share you, right? Thank you. God bless you.